Welcome to our lesson on solving quadratic equations. A quadratic equation is a second-degree polynomial equation in the form ax squared plus bx plus c equals 0, where a, b, and c are constants, and it is not equal to 0. Today, we'll learn 3 different methods to solve quadratic equations, factoring, completing the square, and using the quadratic formula. Let's start by understanding why we need different methods. Our first method is factoring. This method works well when the quadratic equation can be easily factored. Let's solve this example. 2x squared plus 5x minus 3 equals 0. Step 1. We need to find two numbers whose product equals a times c, which is 2 times negative 3, giving us negative 6. And these two numbers should have a sum equal to b, which is 5. Let's try different pairs of numbers that multiply to negative 6, and 1. Their sum is negative 5. Negative 3 and 2, their sum is negative 1. Negative 2 and 3, their sum is 1. Negative 1 and 6, their sum is 5. So the numbers we need are negative 1 and 6, since they multiply to negative 6 and add up to 5. Step 2. Now we'll rewrite the middle term 5x as the sum of negative x and 6x. 2x squared plus 6x minus x minus 3 equals 0. Step 3. We'll factor by grouping. First, we group the first two terms and the last two terms. Open parenthesis 2x squared plus 6x close parenthesis plus open parenthesis negative x minus 3 close parenthesis equals 0. Now we can factor out common terms from each group. 2x times open parenthesis x plus 3 close parenthesis minus 1 times open parenthesis x plus 3 close parenthesis equals 0. Step 4. We notice that x plus 3 is a common factor, so we can factor it out. Open parenthesis 2x minus 1 close parenthesis times open parenthesis x plus 3 close parenthesis equals 0. Step 5. Using the zero product property. If a product equals 0, then at least one of the factors must be 0. 2x minus 1 equals 0, which gives us x equals 1/2. Or x plus 3 equals 0, which gives us x equals negative 3. So the solutions to our equation are x equals 1/2 and x equals negative 3. Let's verify our solutions by graphing the quadratic function. The graph of y equals 2x squared plus 5x minus 3 crosses the x-axis at x equals negative 3 and x equals 1/2. These x-intercepts are precisely our solutions. Our second method is completing the square. This method is useful when the quadratic equation cannot be easily factored. Let's solve this example x squared minus 4x minus 5 equals 0. Step 1. First, we move the constant term to the right side of the equation x squared minus 4x equals 5. Step 2. To complete the square, we take half the coefficient of x, which is negative 4 divided by 2, giving us negative 2. Then we square it, giving us positive 4. Step 3. We add this value, 4, to both sides of the equation x squared minus 4x plus 4 equals 5 plus 4. This simplifies to x squared minus 4x plus 4 equals 9. The left side is now a perfect square trinomial. Open parenthesis x minus 2 close parenthesis squared equals 9. Step 4. Taking the square root of both sides, x minus 2 equals plus or minus 3. Step 5. Solving for x. If x minus 2 equals 3, then x equals 5. If x minus 2 equals negative 3, then x equals negative 1. So the solutions to our equation are x equals 5 and x equals negative 1. Let's verify these solutions with a graph. The graph of y equals x squared minus 4x minus 5 crosses the x-axis at x equals negative 1 and x equals 5, confirming our solutions. Our third method is using the quadratic formula, which works for any quadratic equation. For a quadratic equation in the form ax squared plus bx plus c equals 0, the solutions are given by x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's solve this example. 3x squared plus 2x plus 1 equals 0. First, we identify the coefficients. At equals 3, b equals 2, and c equals 1. Next, we calculate the discriminant. Delta equals b squared minus 4ac. Delta equals 2 squared minus 4 times 3 times 1. This gives us delta equals 4 minus 12 equals negative 8. Since the discriminant is negative, the solutions will be complex numbers. Now, let's substitute the values into the quadratic formula, x equals negative 2 plus or minus square root of negative 8 all over 2 times 3. Simplifying x equals negative 2 plus or minus square root of negative 8 over 6. We can express the square root of negative 8 as I times square root of 8x equals negative 2 plus or minus I times square root of 8 over 6. Since square root of 8 equals 2 square root of 2x equals negative 2 plus or minus 2, I times square root of 2 over 6. Further simplifying x equals negative 1/3 plus or minus I times square root of 2 over 3. So the solutions are x equals negative 1/3 plus I times square root of 2 over 3 and x equals negative 1/3 minus I times square root of 2 over 3. Let's visualize the graph of this quadratic function. The graph of y equals 3x squared plus 2x plus 1 never crosses the x-axis, which confirms that there are no real solutions, only complex ones. Let's summarize the 3 methods we've learned for solving quadratic equations. Method 1. Factoring works best when the quadratic equation can be easily factored into binomials. We set each factor equal to 0 and solve. Method 2. Completing the square is useful when the equation can't be easily factored. We transform the expression into a perfect square trinomial plus a constant. Method 3. The quadratic formula works for all quadratic equations. It's particularly useful when the solutions are complex numbers or irrational. When choosing a method, consider if the quadratic expression can be easily factored, use factoring. If it is 1 and factoring isn't straightforward, completing the square might be elegant. If it is not 1 or the solutions look complex, the quadratic formula is often the most efficient approach. Thank you for watching this lesson on solving quadratic equations.